Yes.
Okay.
Yep.
Now, I did want to say that in today's, we almost want to call it like a hybrid type situation. We have 66 slides and all in this PowerPoint, and we're only going to probably go up to about 44. So that leaves 20 more slides. So I'm suggesting that you also, because I've already uploaded the PowerPoint, and I actually made a little change. So I'm going to have to change the upload. I'm just going to replace it with the newest version. But you're going to, I suggest that you basically, you can inspect the rest of the slides. I mean, obviously, we're gonna go through it with some scrutiny in the next week when we are in person. But I'm just saying you'll have them in front of you, because today I'm just gonna review a little bit and do a little review and then work on the new stuff, the new things. And I don't want to throw too much at you, or else you're just going to hear me, but you're not going to absorb what I say. Okay, if this is making sense. Now, prior to me beginning to spout off and rant about Java, like I like to do, like I am wont to do, as they say, does anyone have any questions about material that we've already gone over? Okay, now for those of you that looked at your week 1 deliverable, the very first one, and you're like, where did my points go? I think I've told you this before. You can get another shot. You can resubmit. If you got a really low grade, it's because either A, you did not label things so that I can easily see them. You may have had the right content, but if it's not labeled properly, I mean, I have 300 students per, this semester, and I don't have a TA, so, I can, I only have so much time to grade each paper. The other thing is, if you actually think, or if you consider, and when I say, I don't mean to sound condescending, because a lot of good, smart people do think this way. They think that, they consider VS Code to be an IDE, and in my opinion, it is not. Now, but if you Google it, if you ask them, is VS Code an IDE, it will tell you that some people do consider it an IDE, some people don't, and I'm here to tell you that, to me, personally, I think VS Code is nothing more than Notepad or Notepad++ on steroids. It is extremely a useful editor. I consider it more like a code editor. And a lot of professionals you may be using VS Code in the future, at your job site. Like when you actually get a programming job, it wouldn't actually shock me if VS Code was actually used a lot, and I know it is. And the other thing that messes people up in their thinking is that you have the actual Visual Studio proper, which some of you have used in other classes, and then you have VS Code. Well, VS Code and Visual Studio were made by the same company. Why is it that they actually have to have the same name or such a similar name? I really don't know. They do this all the time in technology. And for you gamers out there, they did it also with the Xbox, because they had the Xbox One X and the Xbox X and the Xbox this and the Xbox. Like, you don't know what the heck you're buying by the model name alone. So it's really crazy. So unfortunately, the IDEs that I will be considering as IDEs are Visual Studio itself, not Visual Studio Code. Other IDEs include, of course, IntelliJ, Eclipse, NetBeans. I kind of named them in the PowerPoint, and I don't want to go back on my PowerPoint because I have it just right now. I don't want to make any adjustments. So if you want to redo it again, but this time do what I say, use the terminal to actually compile it. You can go ahead and use a code editor, text editor like Notepad++ or VS Code to edit it, but you have to use a terminal to compile it and label it as such, and also do the same thing with idle. And this week we'll kind of have a similar kind of in-class assignment, but this time I'm just going to say use anything that you want. So anyways, that's just an aside. If you want to resubmit your ICA 1, if you did not get the feedback that you wanted. And if you don't mind, I gotta grab my drink. I'll be right back. Okay, all right, so I just wanted to review that we went that we kind of we started off talking about variables, and we decided that there are really two types of variables, what we refer to as primitive, such as integers, booleans, floats, and doubles. And then we decided, in the interest of simplicity, that we said a reference variable is anything that is not a primitive. So the dichotomy essentially is primitives you would define as simple type of variables, whereas reference type variables are more complex. Now, we also said that a reference variable is referred to as a reference variable, quote unquote reference, because when we refer to the type of variable, the actual type is derived from a pre-existing class that has been created or typed out in either our local program or our local application, or has been imported from an external package. Either way, the class has already been created. So when we create a variable of a type of a class that we have already created, we can say that we're referencing that particular class. And then we went over the fact that a class is generally divided up into two parts. The first part is the data fields, or the attribute fields, or attribute data. And we also refer to those types of fields as initialization variables, or IVs. So that's the first part. The second part are what we call methods, and those are things that we can do with said, I guess you could say, said thing that we're creating, said class. So if we instantiate that class, we create what is known in Java as an object, and an object is going to be based upon the object-oriented program paradigm, okay? And with that object, we have access to all the attributable data and method data that is in the original class, and we can say we are creating an instance of that class. So the biggest difference syntactically between a primitive variable and a reference variable is the dot operator is not used in a primitive variable. So I'm going to take a risk and actually write on here, just to use this almost as a whiteboard. If we say int a is equal to 3, and we want to be equals 3. If we said a dot, nothing would happen in the IDE. There's no predictive text that would occur. However, with a reference type variable, let's say we have, for example, in this particular case, I did in one of the further examples, I created the car class, and I created methods like drive and purchase and sell. So if I said car, and then I named the type of variable, we'll call it my car, and then we could say equals, and then new, and then new car, and I went like this, and I could say, now we've defined a reference variable because my car is a reference variable. It's referencing the class called car that I created in this example. So we can say my car and use the dotted operator, and now the dotted operator has access to all of the methods and attribute data that was created when the car class was actually originally typed in. So the difference between primitive and reference is several fold. Some people say twofold, threefold. It just is this. It's the fact that if we said int a is equal to 3, and then we decided to do a and then use the dotted operator, nothing happens because the primitive is broke down as far as you can go. It's like water is 2 parts hydrogen and 1 part oxygen. You can't break down hydrogen and oxygen anymore because those are elements of the periodic table. You literally can't break them down anymore. Now, I hope nobody's a chemistry major because I'm sure you refute me. I'm just trying to think of just a typical example that we can touch it. And when you do that, they're not perfect, but you understand what I'm saying. A is a primitive. That's all you can do. Whereas my car is a reference variable, and they consider it complex because you can do more stuff with it because of the dotted operator. And it's unfortunately the size of a reference isn't as predictable as a primitive is. Okay, looking back here, and a primitive versus reference, again, I'm not going to go through these. We've already done this, but you can see that this is example. Now how you tell the compiler to create the space and memory for each of these variables is a little different. Okay, so if you did int a equals 3 semicolon, because an integer is going to be a certain amount of bytes, I believe it's 4 bytes. It knows that A will be 4 bytes, okay, no matter what. And that is the reason why anything over 2.5 billion or whatever the upper constraints is for an integer, if you declare a as an int and you try to call it 3,500,000,000, this, that, and the other, it's going to give you an error because it doesn't matter what you think it will be. An integer, it exceeds the memory constraints of what an int is, so you have to go and define it as a long, which is why Java, being a type language, necessitates that you plan ahead what type of data you will be having or in what context the application is. And then you also have to worry about growth. So as you're if you're doing accounting for an enterprise, okay, you're gonna wind up with calculations in the millions, right? So an int might be fine, but if your enterprise gets gobbled up, and how companies like Cisco and other companies like that are wanted to do, then suddenly you're dealing with more records, you're dealing with more assets, you're dealing with potentially higher calculations. So you might have to put out an engineering change request to reconsider changing your int variables to long typed variables, if this is making sense. But whatever it is, the good thing about primitive variables is that there's a predictive amount of space that is going to be used. Now, when it comes to reference memory, the new keyword that I kind of demonstrated before is used to allocate the memory. Okay, so a primitive is considered to be kind of like a container of a predicted size, and a reference class is a blueprint only. Now, I told you about the differences, like walking into a new sub and the houses look kind of similar, maybe not Whoville itself, but the houses may look similar, and that is because they're all created from the same blueprint. They're all colonials. They all have the front door at the approximate location. They all have porches that look kind of the same. They all have the big picture window on the right hand side that kind of juts out, and they have a standard window on the other side. One house might have a slightly different hue of brick. One might have a mailbox or a stone lighting built into the home. Others may not. A lot of it depends on what the original, maybe the builder has sold a plot of land already and the new owners have put some changes of their own. Maybe they want that light stone in the front and all that. What I'm saying is that primitives are more predictable, and int a equals 3, int will always be 4 bytes no matter what the value is. References are a mirror instance of the blueprint, so the size is going to be relative. And that is because we have the freedom to define new sub-instances of those instances because of the dot operator. And we have here, and let me just go through some of the changes right here. Now, the reference variables are referred to as references for a couple of reasons. First of all, when we define the references, okay, when we define a variable that's a reference variable, the type refers or references a class that has already been created. Now, there's another reason why we refer to reference variables as reference variables. Here, a primitive, when we define a primitive, if you can please take a look here, we have int a equals 1. We have int b equals a. Now, what does that mean? First of all, what are these? Are these reference variables or are they primitive variables? They are primitive variables, and we know this because, well, first of all, int refers to a primitive type, and if we said a dot, nothing would happen. So it's just a equals 1 and b equals a. But it's also a difference in how the Java compiler stores primitive variables versus reference variables. Primitive variables, the int a is what we call a container, okay? And it's like this. My coffee cup is like a container, and it contains coffee. So when you look at the compiler, it will say it would say something like string a equals coffee, okay? So it refers to the exact thing that's in there. So if you looked at the table of what your computer sees, it associates a literally with the value that we defined in this primitive of a equals 1. But look at this. What if we said int b is equal to a? What your computer sees is b is equal not to a, but it is equal to the number 1. Okay? Now what happens is, as it says, it's stored by value, so it's stored by value separately. And what that means is they're distinctly piped together. Okay, they're associated with them, but yet they're separate. A is 1 and B is 1. So if we change B, A does not change, and I'll prove it to you. So we said int A equals 1, B equals A, so that stands. So in what we're trying to say is when of the way the Java compiler stores primitives is it stores the actual value. So if we said int a equals 1, b equals a, a is assigned 1, b is assigned literally the number 1. However, if we said, did somebody have a question?
Yeah, we can't see the slides anymore.
Oh, okay. Thank you for letting me know. Can you see now? Can you see now?
Yeah.
Okay.
Yep.
All right. So, as I said, if we make a change, if we said a equals 3, okay, and now we have, if we printed out A, concatenate an empty space, and then concatenate B, now believe it or not, A is 3, but B still remains 1. And that makes sense because at the end of the day, we've now associated A with the number 3, but we didn't even touch B. We didn't even mention B. So B is the same because they are stored separately. That's the way the Java compiler stores primitives. Now, the way it stores references is that, let's say we had this program right here. So we have car, which means my car is the variable name. It is referencing the pre-made class that I made up here. This is just like a copy and paste of IntelliJ, but above the main method is a class that I created called car. And the reason why it's not shown here is because we're not going over classes yet. I'm just giving you a taste so I can show you the differences of how Java stores objects, or better known as instantiations of classes, versus primitives. So that's all we're worried about is memory storage. So we're not worried about talking about classes right now. But right now, all we're doing is we are defining my car as a name of a variable of type car. Now, this type of declaration is called creating a reference variable as opposed to a primitive, because my car, the variable name, references the class called car. Now we have equals. Equals is what we call a linker. So it links the variable name my car to the class that is literally called car. And we can see there is an open and close parentheses. It looks suspiciously like a function, but trust me, it is a class name. Now, the open and close parentheses refers to the fact that we are using what's known as a default constructor. So if you take a look at this line of code in Unison, if you isolate this one new line of code, that's what we call a default constructor. So what the new keyword does a couple things. It facilitates our ability to construct an instance of the car class, and the name of the human readable name of the instance, we can think of it as my car. Even though it's a variable name, it is also the human readable association to the instance that was facilitated by the new command right here, new, and together this entire line of code we call it a default constructor because it constructs a new instance of the car class. Now, the name of the instance is my car, and because we can now my car using principles of OOP, we have my car, and this is the dotted operator. And what this means is we can go back to the actual class that I created right here, and I declared make and model as a string, and the only action word or method is status right there. But like that's like going too far. I don't mean to go that far. I'm just showing you how this originated. So we have my car dot make equals Ford, and my car dot model equals Fiesta. Now just forget about status is like it's going to print it out. Ford Fiesta right there based on the all we're doing is here, let me just do this. That's all this is like the all these drop down boxes is IntelliJ. Anyways, all the status is doing is I'm just asking it to print the make and model, and that's about it. So let me just, I'm not, you're not really supposed to see that. I'm just trying to give you the context of why that was written that way. But anyways, so my car dot status, I'm asking it to actually print out Ford Fiesta. Now, the main reason we're on this slide is I just want to show you, whereas the primitives are stored in their own separate lane, objects or reference variables are stored not with their actual values, but they use the actual location in memory. Okay, that's why I have it written like that. And let me make it a little bit better. The memory location is actually what is stored. What I mean by memory location, I mean like a C++ pointer, and I'm thinking that most of you did have your C++ before, so you know all about pointers, and the reason why pointers are a thing is because pointer arithmetic is lighter processing wise on these compilers, and we all have to be concerned about that, because you should know that, especially with applications that are out there like Palantir with Peter Thiel and his teaming up with Elon Musk, and Elon Musk is Doge. I'm just giving you an example of how they are tracking us. So if we are pulled over by the police and they're using the Palantir system, and more jurisdictions are investing in the Palantir system, they're able to track. They're from one search of your name, and so they're able to get as your social security number, and with Palantir it is actually linking your social media too. So if you're being pulled over and maybe a year ago you made a Facebook post that said F the police, how do you think you're going to be treated? Okay. So I'm just saying that the more they're tracking us, the more data they're going to have, and like if you do like simple multiplications, if you're multiplying 3 times 5, that's nothing obviously to a computer. But if you're multiplying 5 million something by 4 billion something, suddenly that's going to add a lot of processing power. So it's a lot easier to move numbers around if you're simply referring to the location, the physical location and memory. So in this particular case, what we're saying is my car.make equals Ford, .model is Fiesta. So my car.make and my car.model are both pointing to the same position in memory. Now what'll happen is here, if we have my car.make equals Ford, my car.model equals Fiesta, and then my car status is going to print out something. But look what happens here. I define my car2, so I define another variable based on the original variable. So it's kind of like how we were saying A equals 1, B equals A, but suddenly we are redefining the what A is, and because they are seen as separate, B is untouched and unchanged because it is separate. Here we have my car2, and I want you to focus on this syntax right here. My car2 equals my car. Okay, so initially my car2 will point to the same piece of memory location as my car make and my car.model. Okay, but what would happen if we just change my car's to.make data and we change it into Toyota? So here's what it is in like a visual type form. We said MC2 or my car 2, we made a change in the dot make data designation. We said instead of dot make as Ford, we changed it to Toyota, and we changed the entire memory location. What do you think will happen to the original my car? Does it change, or do you think it stays the same? What do you guys think? If we ask it to print out, so my car dot make equals Ford. We then said my car 2 equals my car, so they're all pointing to the same memory location, okay? And now we said my car 2 dot make is Florida, okay? Does it change the status of dot make, my car dot make, or does it not? Yes, it will. So let's go ahead and print out my car status, and guess what happens? Toyota Fiesta, Toyota Fiesta. See that? So first thing I wanted to print out was the my car 2 status of Toyota Fiesta, because I changed the dot make to Toyota from Ford. And then I said, what is the status of my car dot status, Toyota Fiesta? So they're all drawing from the same memory location, because reference variables store not the actual value, okay? They store the memory location reference. So that's the other reason why reference variables are called reference variables. Now, we talked about strings, and we talked about the notion of string literals, and then we have the fact that then we talked about how strings, in fact, are classes themselves. And what that means is, yes, that means we do, if we said something like string A equals dot hello, that means we can do a dot, and we can use the dotted syntax, right? And we can now reference all the methods that are available to us. Now, notice that if we try to use the new syntax with string, it gives you an error because it's redundant, because it's already been done for you in the background. String is just one of those classes that have already been instantiated. So all you have to do now is just say string str equals hello world, and then we can say system out print line string, okay? And keep in mind, This is a string literal is kind of like, and I mentioned the other day. Has anybody ever heard of the actor Will Ferrell? And somebody said yes. And if you ever seen Anchorman, and one of the funny lines from that movie is, as the Anchorman, Will Ferrell's character will read whatever it says on the script, and somebody adjusted the script for him to say something goofy and funny, and he read it and he even realized what it was, and that was a joke. It's kind of like in programming, in which whatever you put between the quotes it will print it out. So if you have a misspell, it's on you if it's between the quotes, because it's literally going to read it, objectively without judgment. It's going to print it out. So, for example, hello, and then Ralph, and you notice that, part of strings is, you have the space here and you have the comma here. So it looks like, an actual syntactically, I don't want to say punctuationally, I guess, correct string right there. And a string is class, so it has what we call members. So we can do all kinds of things with the string class. So we have message.1. Message1 equals hello. Message.1 we can say ends with, and you can see it has a Boolean value. It has a Boolean value. So what this means, what do you think this choice in IntelliJ actually means? What is the end result of ends with? What is the I'm going to say type, what is the return value of ends with as a method? It's a Boolean, because we can see it right here. So what do you think ends with actually does? I think it maybe it tells you whether or not something ends with a certain something in there, within the suffix. Okay, so what good does that do? Well, let's say you're working for the evil BlackRock, okay, and there was a list of several properties, and property addresses. So let's say you wanted to filter out all the property addresses that ends with a certain zip code, because the last part of every address is a zip code. So let's say you said something like, if this, maybe you created a for loop to automatically cycle through or walk through like these reams of 500,000 addresses, and you said the logic was, if the method of ends with, my zip code is 48316. So maybe you could say, if the zip code ends in 48316, it would come back as true. So you could say, if the result of this particular method is true, then copy this address to this other list. So you wind up filtering, you're winding up being able to filter by zip code. Okay, so and you can see the example here. Dot message to dot ends with a double exclamation point. Okay, now I'm not going to go over all these. For example, message.to, we now have access to the method or member called index of A. So for example, message to the index of A would be, let's see, 0, 1, 2. The result would be 3, because index of is asking you for the position of A. Okay. Now what good is that? You can think of like maybe encryption, so you can jumble a name predictively, or jumble a field predictively. And then that means you can unjumble it, so you can decrypt it using symmetrical keys. Okay, and remember, strings are immutable. By immutable, it means you cannot change it. And how it means in this context is also, here we have message to replace A with Z. Now, old char or old character right here, that's not something you type in. That's something that's automatically presented to you by IntelliJ, so you don't have to worry about that. But here you want to replace A with Z. So if you printed this out, it would say RZLPH. but because strings are immutable, if we went ahead and if we did this method right here, we're expressly asking it to replace A with Z, but it won't. It'll show you the result temporarily, but it won't replace it because strings are immutable. Strings are immutable. Now and I know we're still kind of reviewing right here. We talked about the difference between a parameter and an argument. A parameter is like a request, an argument is like a response. So a parameter defines a method's signature. So a signature is the method name and the parameters that it is asking for when we execute or we do what we call a method or function call. A call is when we type out the method name with actual arguments, okay, and we execute that method. That is what we call a method call, okay? Escape sequences, okay? So you can have a quote within the quote, and we can do that because we have told it that this open and close parentheses has nothing to do with the syntax of Java. We expect the compiler to read the quote as part of the string literal. If we did not have these escape sequences, then how would the compiler decipher the quote within a quote that we intend versus a syntactically erroneous typing by the programmer? It would not be able to do that, okay? Now, as an example, right here, and unfortunately, I'm just going to. Well, let's just say we said sys. We can do that shortcut right here, and let's say we said something like hello world, and let's go ahead and run it. Hello world right there. Now, if I said this. It gives me an error, and I guarantee you I'm not going to be able to run it. See, expected. It's not. It doesn't know what to do. So and I could just do this and just do that, and then run it, and then it does it. Now, what is the purpose of something like that? It seems quite ridiculous. Why would you ever want to type that? Well, there's a lot of reasons. If you're writing prose for a script and you happen to need to print it out in some sort of a Java program, whatever, you need to be able to have utilize things like that. And every language has that. So, like, for example, languages like Perl might use, or PHP might use the $sign for variable names. So if you have a $sign between quotes, you even, like, I can imagine maybe a compiler not even knowing why you're putting a $sign, but maybe there's a reason why the $sign has to exist within the quotes. And another justification for escape sequences is if you're specifically referring to a file directory of a Windows or a system. Like a lot of things where apps are there to help you manage your system. So to help you, like maybe you're creating, an application to help manage your files or something. So you actually have to refer to directories, and of course Windows directories, are use the backward slash. Of course, and then but Unix directories do the front slash. Like I'm on Unix right now, so here's an example of my directories right here. And if I do present working directory, that is my present working directory here. You can see you're using the front slash. So maybe it's not quite as bad if you're using Unix type directories, but look at this. This is a backward slash. Now the reason why we need two backward slashes, or the reason why we need an escape sequence for this backward slash, is if our directory starts with a T. Like I can imagine somebody that has a Windows computer may have a directory by the name of temp. Okay, TEMP. Does anybody have any misgivings about typing out backslash temp as a string, do you think anything could happen?
Would it see it as a tab?
It would see it as a tab. Thank you, Cole. Very, very good. Thank you for being engaged. Yes, it would see it as a tab. So to prevent that, you actually have to escape the backslash. So that's why for backslashes, you have two escape characters. And as we were talking about, we have the new tab as backwards T. So John entered the room. Now we have backslash N. That is new line. So we have John entered the room. John entered the room and exclaimed, Eureka! And exclaimed, Eureka. That was a big thing in, if you've ever seen 50s movies and 40s movies, everyone was everyone had to act their iconic role, like police officers in New York always spoke with an Irish accent. If you've ever watched like old Batman episodes with Burt Ward and all that, the police always spoke with the Irish accent. Scientists always would have like the vials of chemicals that were steaming, and then when they actually in movies, if a scientist actually came up with a new invention, he would actually say Eureka. In movies they would actually have scientists that say Eureka, and then child actors would say things like gee whiz, Dad. You know, those are actual things in movies. So yeah, that's why you need things like a quote here, because you could reasonably have Sue said Eureka, or Sue said hello world, or something. And then of course the backward slash T is tab. So John entered, and that's a new line, entered at the, and then the room, or entered the, and then you can see the tab right here, the space right here, okay? Now, I'm thinking that maybe, just for fun and play and frolicking, we could have, like, I could challenge you to, maybe, write, text like, T, and then T, and then T, and then T, like that, almost like a bullet, something like that. And I could just challenge you to only use, formatting type backslashes. You're not allowed to use actual spacing in a string. That would be something fun, right? And you can use your backward spacing. Now let's talk about arrays. Arrays are killing us. You probably were not expecting me to say that. Now, you've heard me talk about how much I hate Palantir and BlackRock. Why would I say arrays are killing us? Any ideas? Well, one idea, the reason why I say arrays are killing us, and I say that jokingly, but it's actually true, is that I would make the argument, the reason why nobody can afford anything, and the idea of home ownership is a bygone fantasy, is simply because there's so much money not in doing things anymore. We've long passed off manufacturing to other countries and all that. Now, what is the biggest commodity? It's no longer oil. It's no longer gas. It's no longer the railroads as it once was with the railroad barons, land barons. It's now information. And when we are now, I would make the argument that we are now the product. And what I'm saying is that when we buy paper towels, or when we use Amazon for literally everything on the sun, like I have friends that use Amazon for their prescriptions and all that. So when we utilize these online services, they're tracking our behavior, they're tracking our buying habits, they're literally tracking everything. And what enables them to do that is the ability to collect data, in data structures that allow us to track multiple things, not one. So instead of saying int a is equal to 3, so you're tracking a 1-to-1 thing, we can now do int array a, okay, is equal to new int, and basically whatever it is, however much you want to track. So now what we're doing is, instead of saying that A is only keeping track of one thing, now we're keeping track of a collection of things. And that, of course, in of itself, by its very nature, okay, has a different, I'm going to use the word I just used, paradigm. Okay, what I mean to say is it's its own thing in of itself, because we're no longer dealing with a one-to-one relationship. We're dealing with a one-to-many relationship, and then it gives certain advantages in of itself. For example, if we wanted to keep track of our bowling scores, if there was no such thing as arrays, we'd have to say game 1, frame 1. Okay, it might be, a set of either 8s, 9s, and 10s. Okay, bowling game 1, frame 2, and it could be laborious. So an array would be, a data structure more suitable to that situation or context, because we, instead of saying frame 1, frame 2 as separate variables, we can now combine an entire game, for example, in one single array. Okay, so now we can compare the composite or summation of several games at once, as opposed to going through the extra labor of taking frame 1, frame 2, going all the way to frame 10, summing it up, and we now have a good idea of how good we did, because quite frankly, it doesn't matter how you did. Like, it doesn't matter if frame 1 is better than frame 2 and frame 2 is better than frame 5 or whatever. You just really care about the final score. So now, when I say this, an array is just a completely different mindset. And an array itself is a mere subset of several collection type data structures in Java. Okay, there's more severe types of array-like structures. There's vectors. There's what we call array lists, and they all have different things in common. But one of the differences that a array and non-array, I guess you could say, have in common is it is just a different array. An array on its own, which is really the most simplest type of data collection data structures out there. That is the simplest type of data structure of the collection area, because there's even more than lists. There's also sets. We'll talk about sets, and there's also the notion of key value maps. Okay, in Java they're called hash maps. In Python they are called dictionaries, and in Ruby they're called something else, and in PHP they're called something else. In JavaScript, for some reason, they're simply called objects. But whatever it is, when we initialize an array, we do have to use the new syntax, because it is an array is an instance of the array type. Now, because it's an instance, we have to initialize it with the new keyword, and the way we initialize it is we declare the type, which is how we declare that it's an array is the empty open and close brackets. But before that, we have to preface it with the type of an array that it is. So the limiting factor of this being an array is the fact that you're dealing with more than just one slot. So if we did int a equals 3, it's one thing and one thing only. Now, because we're dealing with an array, we're dealing with at least one thing, but it's probably going to be more things. So in here, it's going to be 5 things. But the limiting factor is because we declared the overall integer as type int, every single member that we express as a member has to be in integer. Okay, so if you go ahead and put in a decimal, like if we say a1 is supposed to be, let's say, the integer spacing, or the amount of integers are there is only going to be 2. If we go ahead and we put 5 and then we try 3.0, it's going to give you an error because we just told the compiler they're all going to be ints. Now, there's a notion of lists. A list is similar to an array, except you can literally put any type of value into it, and we'll get to it when we get to it. We're not doing that right now. Can somebody tell me, like, lists sound like they're going to be more flexible, and arrays seem like they're way more strict. Can somebody tell me any advantage that, why would you ever select an array as a data type versus a list if lists were available, and lists are so much more flexible? Can somebody tell me the advantage perhaps of an array versus a list?
Aren't arrays a little bit faster than a list?
Absolutely. Yes, they are faster than a list and better for memory. Thank you, Ivy. And thank you, Ethan. Now, the reason why arrays are better for memory is kind of like, you like, think of buying a car. When you're young, like you guys are young, you're not going to worry about, electronics. You're not going to worry about the niceties. You're not going to worry about seat warmers. All young people like yourself care about is it going to start up in 10-degree weather? Is it going to get my ass where I need it to go? That's all we care about. So chances are, as a young person, you're probably going to buy a used car. It's going to be money-wise much cheaper than a new car with all the bells and whistles. It's the same thing here. If you know ahead of time that they're all going to be ints, and you know that, your data is going to be a certain length, then yeah, why wouldn't you use the cheaper item? And the reason why arrays are cheaper is because there's just not as much stuff that you can do with an array that you can do with a list, but you may not need to do all that other cool stuff. Kind of like if you're a student, we would all love a new car with all the bells and whistles and the latest electronics, but you're young. All you care about is getting from home to school to work and running errands for this, that, and the other. That's all you care about. So you're going to go with the cheapest. So that's why, especially in the long run, when you're dealing with potential records that could be in the millions, memory is a consideration. Processing power is a consideration. Arrays in action. So, for example, we have int a equals 1, and that is just a primitive, but here we have an array, a1 equals new int 5, so now we get a1 position 0, which is that first position, that is 21, a1 of 1 is equal to 8, a1 of 2 is equal to 23, but here, look at this, a1 of 6. Do you think that is an issue? Can somebody tell me whether or not that is an issue?
Yeah, that would be an issue.
Yes. That's an issue. Well, because of why?
Most data structures like this are going to start from 0, and it's just kind of like the role of computer science most of the time. So going to 6 would be out of bounds. There you go. And take a look here. I actually tried to run this, and with the hopes of getting the most appropriate error. And yes, array index is out of bounds. Okay. Now look at this. If we tried printing the array here. Now we have our array, a equals 21, a1 is 8, a2 is 23. Now if we printed a1 itself, we wind up with this gobbledygook right here, which represents, okay, the address of the memory in the first position. So it's like telling you that it's not going to allow you to print it because it's just treating this as an actual object. It's not a literal array. Like it conceptually, you can look at it as an array, but the way the compiler treats it, it treats it as an object. So it doesn't. You just can't print it like that. So what we're forced to do is there's a couple ways we can actually do it. We can use array, okay, and we have the array list. We can import that package, but when we do that, we have access. We again
can print A1, but we can say arrays to string of A1, okay? And just so you know, we actually, I'm sorry, this should be up here. We're actually importing the Java arrays java.util right here, and we can see, and we just press tab, just double click on it, and IntelliJ will automatically import the arrays class or package from here's the arrays class from the java.util package right here. And because of that, we now have access to arrays.toString right there. Now because this arrays class, because it's just so you know, it's probably programmed with the static keyword, the class is. And what a static class is that means it does not need to be instantialized or instantiated before usage, so we can just call it arrays itself. Notice we have arrays here, and arrays is on the bottom. So just by typing arrays, we don't have to create an instance of arrays. You know, where like normally we'd have to say arrays, and then we could say foobar equals new arrays. We don't, and then we'd have access to foobar dot, and we can use the dotted syntax. But we don't need to do that. We just refer to it expressly because that is what we call a static class. And so because of that, we can say arrays, and then now we have access to all those juicy method members, okay? And one of them is toString. And what is the parameter that toString is looking for? It is looking for the very thing that we want to string out, and we're using A1 as our argument right here. So what this does, it turns the array into a string literal. And then what it does, it will allow us to actually print it out. So system.outprint line arrays.toString. And A1 is the argument. And argument, because of this, now it is a string of 28.8. Now, the reason why that there are zeros is because when we declare any discrete structure or any primitive, there's what we call the default value, okay? And so the default value of an empty integer is actually 0. So when we declare A1 0 and A1 of 1, what happens to the other missing entries into our little array right here? What happens to them? Your compiler will automatically fill them in with the default value as if we never declared it, and we never did declare it. So consequently, the full array as it's being read out is 21, 8, 0, 0, and then 0. Now the other way of printing an array is using the for loop. And here we can also use the toString method. Here we are again using the toString, but we can also use the for loop. Now here's an example of using a string, and just so you know, I'm not expecting you to know the for loop simply because we haven't gone through loops yet, and we haven't gone through if statements, so we will do that next week. So in terms of actually printing an array, you would prefer right now to use the toString method approach. Using a string array, we have string A1 equals new string, A1 of 0 is 2B, 2, A1 of 1 is B, A2 of 2 is OR. Now what would happen, because we declared string as having 5 members, but we only declared 3, so what are the rest? Null and null. Because the default value of an uninitialized string is the word null. Using a boolean, we have boolean A1 equals new boolean 5, A0 equals true, A1 and A1 of 2 is true. So what would happen if we printed the string value out? What do you think the default value of a initialized Boolean type variable is. You know, Booleans are either true or false. So the I'm not going to wait for an answer because I just want to get through this, and time is not our friend right now. The default value is false and false. So I'm hoping everyone is following what I'm trying to say, that when you declare a variable and you only express a portion of or when you declare an array, my fault, sorry. When you declare an array and you don't initialize it with specific variables, and you only are defining a portion of that array, the compiler is going to fill the rest in, okay, with the default value of that variable type. And when it comes to Boolean, the default value is false. When it comes to a string, an array, the default value of an undeclared string is null. The default value of an undeclared integer, of course, is going to be 0. Now, there is yet a newer way to declare an array, and that's not even, it should not even be called a declaration, or we shouldn't even call it a way to declare an array. We should really call it in full-on initialization, because the new way of doing this is int a equals 1, int array a1 is, and here we're just filling in all the values. We have open and closed curly braces, and within the curly braces is our entire array. And because we've declared it from start to finish, we've actually expressed our values from start to finish, there is no need for the compiler to have to fill in the missing spaces, because notice we did not have to declare the size of it, because there's no need to. We've actually declared each and every value from start to finish, so it can count on its own. 0, 1, 2, 3, 4, 5. And we can simply use the toString method to change this from an array of integers to strings. And now it actually prints it out right here. Okay? And we have, and because arrays is an object, it's not a primitive, it uses primitive types within the object, which might cause some confusion. Here I'm calling it not a primitive, and here it's prefaced by a primitive, but it's just simply there because arrays force you to be consistent with the type. Now, why is that? Because the Java compiler prefers predictive memory allocation as opposed to reference variables, which have a very unpredictive type of memory allocation. So by using a primitive as the basis of the array, it knows it's going to be at least a certain size, because when we declare it the old way, when we just say int a1 is equal to int with let's say we had the number 8 as the amount of spaces, it knows it's going to be 4 multiplied by 8. It knows every declaration or every single initialization or instance of that array is going to be 32 bytes. You can initialize an empty array even, and that's going to be 32 bytes. That's just the way it is. But the advantage of an array is, hey, it is still an object. Even though it's highly limited, it's still an object, so it does have access to those method members. One of the method members is length. So we have a1.length, and notice, oh, my apologies. Length is not a method member. Length is a attribute or instance variable. So it does not get the open and close parentheses that a member method would get. So what happens in the background, what the array object does is when we declare an array, it automatically infers the length value when we create it like this. So because of that, if we just type in a1.length, it will actually print the length, which is in this case 1, 2, 3, 4, 5, 6. We can also use the sort method right here. And just so you know, this may take this may take some time, some typing out for you sometimes to really understand these things. Maybe it's best to actually type them out yourself too, and then you can really understand this. The array method is overloaded. Okay, so what I mean to say is that, or the array class utilizes method overloading. So, for example, if we typed out arrays and we did the toString right here, there's different toString methods, and they're overloaded. What method overloading is when you have multiple methods of the same name, but the method signature is different. Okay, so in other words, there's a toString method for ints, integers. There's a toString method for bytes. There's a toString method of chars, longs, floats, shorts, and doubles. But they all have the same name called, they all have the same name, method name. They're all called toString, but they take different parameters. So we can say that those are different method signatures. And when you have different method signatures and you have of possibilities with the same method names, we call that method overloading. Now we have what we call multi-dimensional arrays. So an array can be defined. Here's an an array. A multi-dimensional array is an array connected to other arrays within the same array. So this is one big array, and then you have arrays that are subarrays of the same array. So an array, a multi-dimensional array, is defined by its row and its column. So if you if this was 0, 1, 2, 3, and then you said 0, 1, 2, 3, and then you had, you were able to define a particular, tile, if you will. How would you define this tile? You would define it, it's almost like coordinates, but the question is, how do you know to define the row first and the column first? Why would you? So, for example, this is row 1 and this is column 1 if we were starting at 0, if that makes sense. Well, how do you know you're not saying column 1, row 1 and row 1? Well, I always use RC Cola as an example because I grew up with RC Cola. It was always a alternative to Coke or Pepsi. And you can still find RC Cola at Kroger and stuff, which I like. Although I don't drink pop. You should stop. No one should drink pop, by the way. Don't drink it. But I always think of the ordering or the coordinates of a multi-level array as RC Cola. So for you first refer to the row, and then you refer to the column. Now with a multi-dimensional array, it definitely has its use because we can establish the top row as column names, and then the columns themselves would help, populate the rows, and then so you can call adjacent columns, you can almost call that an entire record. So in other words, you can keep track of customers, so you'd have customer number, customer name, address, and then you can have their ordering history or something. So it's a great, and this is how arrays are used with other arrays to create multi-dimensional arrays. And now you can see how multi-dimensional arrays can be used in conjunction with each other to help keep track, of buying habits, of product habits, and age and geolocation, data, and things of that nature. So we have a two-dimensional array right here. So how do we define the two-dimensional array? So here we can create a 2x3 matrix. So we have integer, and then we have the first level and the second level right here. And then we just tell it that the matrix is 2x3, and we can help define the each one. So numbers, and then that is the first row, or the 0 row and the 0 column. That is going to be equal to 1. And then when we have to print the multi-level array, we have to use the deep toString method, not simply toString. We have to go, I guess, more in depth. I mean, I don't write these method names. They're already done for us. So, but, we have to utilize the deep toString method. So now it's going to print out 1 0 0 0 0 0. Now we have the three-dimensional array. So to make a three-dimensional array, we simply initialize the integer with 3 empty brackets, and we just call it numbers, and then we say it is going to have 2, 3, and 5. Okay, so now we define the 0 0 0 position as 1, and now if we did the deep toString numbers, we now have this, because it's going to automatically fill in all the missing data with the default integer variable or value, which is 0. Okay, now we can also use the new syntax. Okay, with the new type syntax, I should say. I shouldn't have put the word new. It's more like the best thing I can do, I should have said, is recent, because we all know new is an actual keyword. So I try not to use keywords in my explanations right here. And again, using just to specify here, when we declare a multi-dimensional array, we tell the compiler int, and then we have the 2 open and closed brackets, the name of the array, and then we tell it, 1 bracket here, 1 bracket here. This refers to the first matrix, and this refers to the second matrix. So here we have the the most recent method. I almost used the new word again. We have int double brackets, numbers equals 1 2 3. That's the first array, and 4 5 6. That is the next array, and we can visualize it by ensuring we keep the R by row by column in place. So if we print it out, we actually have 1 2 3 and 4 5 and 6. Okay. Now sometimes we don't want to we don't want the value of a variable to change. So for example, let's say we declare pi as a float. Now notice, what is that F right there? If we go back to, and let's just make sure. Okay, 38. I'm just going to write 38 so I can keep track. I should not be making PowerPoints that are like 60 slides long because it gets to be sometimes hard to track. But we want to tell it to remain afloat because 3.14, your computer may implicitly, I'm going to say, adjust the value to a double. It might consider it a double, and you don't want to do that if you want to keep it as a float. So to make sure that your system retains 3.14 as a float value. And okay, so some things could happen beyond your control. So the next guy might come along and might combine pi with a double, and suddenly your compiler will implicitly convert this 3.14 into a double. And for space constraints, maybe you don't want that. Okay, so if you wanted to be a float, but you wanted to stay as a float and not somehow be implicitly converted into a double later on, you actually do have to, it is sometimes best practice to put the letter F here in next to your value, so it make sure it stays as a float all the way through. Now, what if, but the whole point of this slide here is here you declared it as a pi, as pi, and its pi is a pretty significant number in terms of geometry, in terms of, numerology, okay? And you will always be some variant of 3.141516, but here you're like, okay, pi is the value I'm working with. It should be this. Well, what if somebody came around and just said pi is equal to 1, and let's say you weren't aware of that, or maybe your system did it by accident, okay? Like, it would be like, unfortunately, Microsoft does this too, because I was up till late last night. I got the RTX 5090. I want to max it out, so you have to make sure your Microsoft Windows is always refreshes at, like, say, 144 hertz. So if there's a Windows update, it sometimes takes it back down to 66. Okay, and I hate that. So things happen. Like if this pi is somehow used as part of a derived class through the concept of inheritance, and somebody uses this class, they could very well accidentally change the value of this pi somewhere down the road, and I have no control of that. So if I then use their derived class to make a calculation, it might not be the same. They do this a lot of times with tax tables and accounting applications. Sometimes there's errors in figures because they're using old tax tables, because a number might be based on an old tax table and you're not realizing it. I'm sorry I'm explaining it too much, but I'm just saying sometimes you just don't want your variable value to change, and you want to make sure that nothing happens in the background or in the future to change the value of your variable, so you can use what they call the final keyword. So in terms of pi being a float type, to make it work for your compiler, you're actually describing the float value as a final value. So in other words, what will happen is if you say int x equals 3, and then you go ahead and change x equals 1, if you print out x, it's fine. And I didn't even print it out simply because, not that it's intuitive, although it is, it's also the fact that we said int x equals 3, x equals 1, and nothing happens. And so this is IntelliJ. And Java, if any little thing happens, it's going to start yelling at you. IntelliJ IntelliJ's interface will yell at you. So if you put the final designation here, final int is x equals 3. If you said x equals 1, what do you see here? What is that? From IntelliJ. That's a squiggly line, a red squiggly line. Now, in IntelliJ, an orange squiggly line or a yellow or whatever it is, chrome color or whatever, squiggly line is just like giving you a suggestion, which it can be annoying. Like just as soon as you declare int a equals 3, semicolon, it's a will have that dreaded orange squiggly line. And you're like, what did I do? What did I do wrong now, Java? And you click on it, and it says, oh, just so you know, you declared a variable, but you haven't used it yet. It's like, no kidding. Of course I didn't use it, because I just literally declared it. Well, you know, but here, it's giving you the red squiggly line. That means that you better not try to compile it. If you try to compile it, it's going to give you an error. Now, why is this red squiggly line under X? Now, I'm not going to wait for a response because A, I know you probably know what it is, and B, time is not our friend as usual. But the reason why there's a dreaded red squiggly line below the X is because we had declared X, the int X, as a final variable. So you cannot go and change it. And by convention, constant, and we call a final variable, we call that a constant. So a variable that has been prefixed with the final keyword, the keyword called final, that is what we call a constant. And simply by best practices or convention, final or constant variables are all in all caps. Okay, and I think I'm going to stop here, other than to say that there are certain arithmetic expressions. I mean, I might as well go over these slides, and we have a couple more minutes left. So this is going to be so intuitive. Int results plus equals 10 plus 4. If you do result minus, it's 10 minus 4. There's multiplication, 10 times 4. Result divide. Now, there's an issue with what do you think the issue is with the division right here? Like, there's no 10 times 4 is fine. But what could be the problem with 10 divided by 4? Now, I will wait for a response for this. What do you think the issue is?
It's going to round the value.
Yes, it's not going to be accurate. So really what you want to do is never have the result of a division as an integer. Have it as obviously a double or float. The result, as it says, will be inaccurate. Okay? And here we talk about casting. We're forget about that. We're going to stop here. I don't want anybody... And the only other thing I wanted to talk about, I wanted to talk about order of operations, but that is in a few more slides, so I'm not going to worry about it. That is it for today. I made a little change of this slide, so I'm going to upload that entire slide, and that means you'll have access to all 66 slides in this deck. So I do encourage you to look ahead and everything, and I'm going to upload a like an after class assignment due in 48 hours, and after that there will be some weekend homework. So anyways, I encourage everyone to please stay warm, stay off the roads if you can. And if you do have to go out and drive, please be as careful as possible. And if there's no other questions, I'm going to end this session. And I'd like to say thank you very much for joining me.
Have a good day, Professor.
All right, you as well. Be safe.
Have a nice rest of your day.
Bye-bye.